coordinate geometry, finding midpoint of a line segment and the length of a line segment. For example, the sort of question we're looking for here is for the line segment between these 2 points, find the distance and midpoint. Now, what I'm going to do first is just have a look at how we get the formulas, and then we'll go back and use the formulas to solve this sort of question. We'll talk about a couple of things. I do hope you all remember the Cartesian plane or the number plane. If you don't, if you were ever a bit shaky with it, go back and check one of my revision videos. The points, of course, the x value and the y value, so -2, -1. You wouldn't necessarily have to give the coordinates here, but I am, and 2, 3, 2 on the x, up to 3 on the y. So what this is asking is for the line segment, because any line is in fact something that goes on forever. So if I have only part of a line, that is the part that's between these 2 points, it's called a segment. Try to actually get it on the point there. And for that line segment, we would like the distance between those 2 points, or the length of the line between them, and we would like the midpoint, which is the coordinates of the point that bisects this line. Now you can see the midpoint, it's pretty much definitely going to be right there. So it's kind of interesting to visualize this, but we'll develop a formula for finding the distance between these and the coordinates of the midpoint without actually having to graph them. So let us look at the midpoint. Now it pretty much looks like the midpoint's going to be here. And if we measured it, we'd see that the midpoint was here, but we do need to be able to calculate that exactly rather than just going, oh look, it looks about like there. The midpoint, if you look at the x values, you can see fairly clearly that the x value of 2 and the x value of -2, halfway between those is 0. And if we look at the y values, here's the y value of 3 and the y value of -1. Halfway between those is 1. And if we take halfway between the 2 x values, halfway between 2 and -2, and halfway between the 2 y values, between -1 and 3, we get the coordinates of the midpoint of that line segment. So for the midpoint, halfway between the 2 x coordinates is our x coordinate of the midpoint, and halfway between the y coordinates, I can't write today, and that gives us the x and the y values of our midpoint. Now, what we want is a formula that will always work. And our problem is I've got 2 different x coordinates, this one, and 2 different y coordinates, those 2. So if I label this x and y, and this x and y, that doesn't work because there's 2 x's and 2 y's and they're different. So we use a subscript. It doesn't matter which point is point 1 and which point is point 2, it will always work. This is x1, this is y1, this is x2, this is y2. So in maths, labeling with a subscript number identifies the thing. So this is x from point 1, this is x from point 2. If I wanted halfway between x1 and x2, That's actually the average of x1 and x2. Negative 2 plus 2 is 0. Averaged out is 0. Let's check halfway between these. Negative 1 plus 3 is 2. 2 divided by 2, because there's 2 points, gets us to 1. And my coordinate is 0, 1. So all we need is a formula that says find the average of the x's, and that's your x coordinate. Find the average of the y's, and that's your y coordinate. And your midpoint formula, capital M for midpoint, do not use a smaller m. Smaller m is for gradient. We'll talk about gradient later. Is in brackets, because we want to get a coordinate, so the coordinate needs brackets, x1 plus x2 over 2, the average of the x coordinates, comma, because I need a comma in my coordinates, average of the y is y1 plus y2 over 2, close your brackets. This is the midpoint formula. And we'll go through how to use it. We also need to find the distance between the 2 points, or the length of that line segment. And if you're feeling very clever, you may have spotted what we've got here already, which is, of course, a right-angled triangle. And if I want to find the hypotenuse of a right-angled triangle, I use Pythagoras. And if my short sides are A and B, and my long side is C, then obviously I need a rearranged formula of C squared is A squared plus B squared. Now, we'd really like just a formula for finding C, the distance. So we square root both sides. C is the square root of A squared plus B squared. That just gives us a formula of Pythagoras in terms of C instead of C squared. Now to get the change in the distance on the y side, I have 3 on the y over here and negative 1 down here, and I quite obviously need the difference between those, and it's 3, take away negative 1 will be add 1, I'll get a distance of 4. So the first y value minus the second y value will get us that change in y. And the change in x, the first x value, and that x value, to go from negative 2 to 2, I will get the change there. So, to find the length of each side, I need x2 minus x1, the difference in the x's, that will be the length of one side, square it, plus y2 minus y1, the difference in the y's, and square it. And if you did get something that gave you a negative, minus 2, or negative 2 minus, what have I got over there, negative 2, sorry, negative 2 minus 2 would give me negative 4, but of course when I squared it, I'd get the positive that I needed. So this is the distance formula. And I'm just going to change this to say distance. Distance between 2 points, or the length of the line segment joining 2 points, is this. Let's use those. Running out of time here. Midpoint, now my points were negative 2, negative 1, and 2, 3. I cannot stress this enough. Don't think, oh, I'm too clever, I'll just read it off. Of course that's x1 and y1, label them. You are likely to screw it up, and I will have no mercy. This is a dead fairy error. Actually write underneath the points, this is x1, y1, this is x2, y2. write your formula. Midpoint is brackets x1 plus x2 over 2, comma, y1 plus y2 over 2, close brackets. Substitute your values. Negative 2 plus 2 over 2, y1, negative 1 plus y2, which is 3 over 2, and from there go straight to your solution. Negative 2 plus 2 is 0, 0 divided by 2 is 0. Negative 1 plus 3 is 2, 2 divided by 2 is 1. That's our midpoint. Distance. Distance is the square root of the difference in the x's squared plus the difference in the y's squared. Sorry about the noise, it's raining outside. So this will be 2 minus negative 2 squared plus y2, 3 minus negative 1, which will be the square root of 4 squared plus 4 squared. Right. Square root of 32, and because I did 16 plus 16, square root of 32. If you were asked for exact values, you'd do 4.4 root 2 units. Otherwise, 5.66 units to 2 decimal places, because I'm saying I've rounded it. So that is the distance and the midpoint formula, and how we got them and how we use them.